All right, so I believe this is recording. Let's take a look at these three equations. They are quadratic equations. The largest exponent that appears on a variable is 2. Um, this time the directions are telling us to solve this by factoring. When you took Algebra 1 or Algebra 2 here at Northview, the teachers got together and taught this in a uniform way, and they taught you a technique, a method that they refer to as the X method. So let's do that for problem number 4. The X method comes in particular handy when the leading coefficient is a number that's different than 1. So you draw an X, and you can do it over the middle term or just off to the side. I kind of like doing it off to the side so that I can still read the original equation. For the bottom of the X, you write the middle term, and for the top of the X, you take the first term times the last term, provided two things. You want to make sure that this is in standard form, and if there's any greatest common factor, you want to make sure that you have factored it out. So it is in standard form. It does equal 0. There is no common factor. And 5 times 8 is 40. So I have 40x squared up at the top of my x. So now I want to find two numbers that when multiplied together give me 40x squared, but when multiplied together give me 40x squared, but when added give me negative 14x. That is called trial and error. So you begin to look at the different factors of 40, and it probably doesn't take you very long to play around and see that negative 10x times a negative 4x does the trick. If you multiply these together, you get the top of the x. If you add them, you get the bottom of the x. So now they got together and they said, well, let's put this information in the form of a table, because they use tables to multiply two binomials together. So it makes sense to use the table to factor a trinomial into two binomials. So the first term and the last term go along one diagonal from the original problem. So I've got 5x squared and 8 that I write along one diagonal, and the negative 10x and negative 4x along the other diagonal. When that diagonal contains two negative numbers and this is positive, you're going to factor out a negative number in both the row and column here. So what's common to negative 10 and positive 8 is a negative 2. And what's common here vertically is a negative 4. And you can see that negative 2 times a negative 4 is positive 8. Horizontally, if we look here, the 5 and negative 4 are what they call relatively prime with respect to each other. They just have a 1 in common, and then the variable x. But then if we look vertically here, both of these are divisible by 5x. All right, so this table has now helped us that we can rewrite this original equation. Instead of writing 5x squared minus 14x plus 8, it is equivalent to write x minus 2. I'm getting that from along the side here, and then across the top, 5x minus 4. And don't forget that that equals 0. You want to write in complete equations. Now we have a theorem that is a product theorem that says if you have a list of numbers that multiply together to give you 0, then at least one number in that list is 0. So we can split this equation into two equations. It must be the case that either x minus 2 is equal to 0 or that 5x minus 4 is equal to 0 in order for that original equation to be satisfied. So here this is just one step. You add 2, and this is a two-step equation. If you add 4 and then divide by 5. So with an exponent of 2 for a quadratic, we were expecting two solutions. They could be repeats, but in this case they're not. So here's our answer for number 4. See if I can shrink this up a little bit to give myself a little bit of room for these other two. I'm getting used to this software, so sometimes it shrinks up for me and sometimes it doesn't. All right, so let's come in. We need this to be in standard form. And we notice here that all of these are divisible by 3, that there's a greatest common factor of 3. So let's divide every term by 3. And we get x squared minus 2x plus 1. And 0 divided by 3 is 0. All right. So with a leading coefficient of 1, many students don't have to necessarily do the x method, because you can just come in and say two numbers that multiply together to give me a positive 1 but add together to give me a negative 2, or negative 1 times negative 1. So if you need to do the x method, you can, but I think that most of you will simply write x minus 1 squared. So here you can see that we get a single solution. It's even though the exponent was 2 and we were expecting 2 solutions, this solution is referred to as a repeated solution. Repeated root is what it's more often called. We have found all of the solutions. That's really why I point that out. If somebody saw, hey, you just had one solution, but the degree was 2, where's your other solution? It's just repeated. It's x equals 1 or x equals 1 satisfies this equation. Let's take a look. Oh, that's not going to work, is it? Let's take a look at this last one. That's this is really neat how these software programs work on this writing. I'm writing on a wireless tablet and showing up on my computer screen. I'm always amazed by it. All right, so this is clearly not in any kind of standard form, so let's get it in standard form. If I subtract x squared from each side, 2x squared minus 1x squared is just x squared. If I subtract 7x, when a term changes sides, it changes sign. So when you take that 7x and move it to the other side, it changes sign. We'll leave the 10 where it is. Again, with a leading coefficient of 1, the x method, although useful, its true benefit is when that leading coefficient is different than 1, especially if it's not a prime number. Like the 5, we still could have probably figured it out in our head. But if that 5 becomes a 12, a 24, a 36, where there's a lot of different factors, it's nice to have an organized way to do this, like that x method. All right, so if we're looking for two numbers that when multiplied together give us positive 10 but add to negative 7, it doesn't. 10 only has factors of 1 and 10 and 2 and 5, and they both need to be negative. So you can easily see that negative 5 and negative 2 adds up to negative 7. That gives us two solutions. Since it was a quadratic, we know we have found all of the solutions. You can have at most two solutions. So there they are. Hey, I hope this helps, and I'll talk to you later.